ascending powers of x. And then they are saying the coefficients of x squared and x are given respectively. So we're having negative 6 as the coefficient of x, and also we're having 27 as the coefficient of x squared. Under binomial, whenever it comes to series, or whenever the power is negative or a fraction, there's that expansion that we're supposed to use, which is simply given as what? We say 1. The condition is that the first term has to be a 1. We don't care what you have here, and the power has to be either a negative or a fraction. The series is always 1 plus na, then plus n, then you have n minus 1, then you have 2 factorial, you have a squared, then plus n, you have n minus 1, you have n minus 2. So it depends really with the book that you are using. Some books are going to give you x where I've put a here. It doesn't matter. The idea and the concept is the same. The first term has to be a 1, and the power has to either be a negative or a fraction. So Omar, you are the one who's asked this question here, the last one, number 13, that we are starting with. You remember this, you've looked at this before, right? We are told to say what's in front of x is negative 6, and what's in front of x squared is a 27, and our question is simply 1 plus what? There is a 1 plus ax to the power n. Yeah, so we're going to use these in the same expression. Let me use a different color. The same thing. So we'll have 1 plus nax. Where there is a here, in our question we have ax. So that's why I'm putting ax there. Then plus n minus 1. Then I'm having 2 factorial there. Then this is going to give us ax squared. Then I leave it here. From here, I'm going to get what's in front of x is the coefficient of x, right? So what's in front of x is simply, they're saying it's a negative 6. So na is equal to negative 6. That's the first equation we make. And the second equation we're going to make is after we simplify this part. This is n minus 1. 2 factorial is the same as 2. This is a squared and x squared. So what's in front of x squared, this whole thing, should be equal to 27. That's what they mean to say the coefficient of x squared was 27. So we need to write this. This is equal to your 27. Madam Oma, is this okay here? Is there any part that, am I too fast, or are you following up to this point? This is equation 1, then this will give us equation 2. Is this okay? This part here. So if we want to proceed and simplify what we have, so we have the guide down here, we can just cross multiply the 2 so that we simplify our expression. We'll get something like this. A squared is equal to 54 when you cross multiply with the 2. Then here I'm going to expand this n squared and an n. Then there's an a squared waiting outside. I'm going to take my time to do this so that you see it clearly and realize that it was actually easy, because from here now the question is number 13 from your tutorial sheet, this guy here, and the question is saying when this expression is expanded as a series, the key word here was series. If they say it's a series, they mean that we are looking at this case. This is the case that we are having, meaning n is expected to either have been a negative or a fraction. You remember this formula here, Madalis, right? This guy here, isn't it? Yeah, so now our question looks like this, meaning wherever there's a, the place of a we'll be putting ax. Then wherever there's n, we'll put n. So we just did the replacement. This is where we are at here. We did the actual replacements, and now we're saying the coefficient of x. What's in front of x is na. That's what we're equating to negative 6. And what's in front of your x squared is what is the coefficient of x squared. That's what we're equating to 27. And we've created 2 equations, and I'm just trying to simplify the second equation, which is down, which is a little bit big, by cross multiplying. That's where we get the 54 on the right, and here I multiply the n with this and the a squared with everything. At this stage, I'm going to factorize na to remain with na here, then minus, this is going to give us a there. This is equal to 54, I mean. Wherever there is na, remember we said na is equal to -6. So we can put -6 there, -6 minus a, then this is equal to a 54. Then here we're simply looking for a, so we can get our a. If we just solve this, we can say this is a 36. This is going to give us a 6a. This is equal to 54. Then you have 6a is equal to 54 minus 36. What is 54 minus 36, guys? What do we get? Oma, what are we getting? This is your question. So if you do the replacement here, we're getting what? We're getting 3 as our a. Now, since na is equal to -6, where there is a, we can put 3. So we have 3n is equal to -6, meaning we can do this. Then we'll get the value of n. The n will just be -2, which is expected because this was supposed to be a series. So the actual question, therefore, is 1 plus 3x to the power -2. This is what the question was supposed to be. It's a series. Not only have we found the value of n and a, we can also find the coefficient of x to the power 3 by expanding this same expression until we reach the fourth term, because it is the fourth term that has x to the power 3. So now we're going to say this is the same as 1 plus -2 and 3x, then again plus -2 minus 1, then I have 2 factorial. This is 3x to the power 2, then plus -2 minus 1, -2 minus 2 over your 3 factorial. Then we have our 3x to the power 3. The coefficient of x to the power 3. So this is the coefficient of x to the power 3. This part here, we're interested in this last part. That will be our main concern. So we'll just have -2, -3, and -4. 3 factorial is simply a 6. Then this is going to be 27, x to the power 3. Then from here, we can try to simplify this. This is going to give us what? This is a 6, that's a 6. We have -4 times 20, 27, x to the power 3. Then if you multiply your 27 by your -4, this gives us 108 with a negative. So the coefficient of x to the power 3 is -108. That's how we solve the last question on tutorial sheet 7. Anyone who has any other questions, guys, from these tutorial sheets been forwarded in the group is saying express 6 choose 2, then plus 2, 6 choose 5, then plus 6 choose 6 as a binomial coefficient. We need it in the form of n choose r. That's what we want to do. So please take note that we cannot multiply 2 with this. 2 cannot get inside this expression. This is fixed. We cannot get anything outside or anything inside a binomial coefficient. So the only thing we can do, this here means these are the two of them. So we can write 6 choose 2, and then we have 6 choose 5, and we have another 6 choose 5. They're the two of them, this part here. Then the last one is 6 choose 6. Remember, if I give you 2x, that means x plus x, right? Yeah, so that's the splitting that we have done here. We just split it. So from here now, we're trying to relate things that are a little bit close to each other. So if you notice, this part can be written. So since, remember, you learned to say n choose r is the same as n choose n minus r. So this part, the 6 choose 2, can be written as 6 choose 4. It's the same thing. Just subtract 6 minus 2. That's a 4. I just want the numbers down to be close. The only difference between the numbers down should be 1. 6, 6. So here, we're going to get these 2 will give us a 7. Then choose 5. That's a rule, right? There's a rule that you proved. We said if you have this, then plus n choose r minus 1. This is the same as n plus 1. Then get the bigger one down. So hope you are able to recall these rules. Then the other part here as well will be 7. Then you get 6. This will proceed to be 8, get 6. So this is the answer that they wanted, where your n is equal to 8 and your r is equal to 6. That's what they wanted for the first one there, Joseph. You've seen this guy, right? Yeah, so we're just playing around the rules of your factorials, your combinations and factorials. Yeah, so these two rules are going to be very, very important. The same ones that you just learn for the sake of learning, they will help you to be able to simplify things. Yeah, so this, and also be cautious with the one they like mentioning about proving. Yeah, so we have this is equal to n plus 1, then choose that. The condition is that the guys here have to be the same, and these ones down have to differ by 1. That's the only condition. No wonder we had to bring or make the 6 choose 2 to become 6 choose 4. Because there's nothing we could have done, because the difference here is more than 1. The difference here was 3. In as much as the guys on top were the same, we could not have used this property for the first two expressions. So we had to bring them close. Now they are close, we can apply the principle. Yeah, so that answers the question there that you have. Any other questions, guys? Look at this document. We're going to start with the first part, the first paper in the document. So this is test 2. It's for last year, but it's for these other guys, for the 1100 guys. Look at the first question here. The first question here says, solve the equation. You have 2n plus 2 factorial over 2n factorial is equal to 30n minus 34. So we're just trying to solve this expression, and if this is what you're interested in doing, you're going to write the expression given as your 2n plus 2, of course with a factorial. Then you have 2n factorial is equal to 30n minus 34. So what's the first step here, guys? What do we do? 2n plus 2 is bigger than 2n, right? So we're going to have 2n plus 2. We'll write this, then minus 1, this is going to be 2n plus 1. Minus 1 again, this is now going to be 2n, then factorial. Then we have 2n with a factorial here, this is equal to 30n, then minus 34. Then we cancel this. When you cancel this, you're going to get 2n plus 2. Then we have your 2n plus 1 is equal to 30n minus 34. Is there anyone who is lost, guys, up to this point? Is everyone okay? Any questions up to this point? Okay, so if there are no questions, then we proceed. I'll expand this by multiplying with 2n. This is going to give us 4n squared plus the 2n. Then this is going to be 4n plus a 2 is equal to, there's a 30n minus 34. This is now going to give us a 4n squared. This is a 6. When the 30 comes on the other side, that's going to give us a 6 minus 30. That's going to be negative 24n. Then when the 34 comes this side, we're getting a 36. So we have this is equal to 0. 2, or rather 4 is common, I think, everywhere here. So I'll divide by 4 throughout. This is n squared minus 6n, then plus, that's going to be a 9 is equal to that. So here we have, this is the same as difference of two squares. If you can just see it closely, this will simplify to that. This is going to be n is equal to 3. Yeah, so here we got our n. Our n here is equal to 3. That's how we solve this question here, guys. Hope everyone is okay with how we manipulated it. The second one, can someone tell us what we're going to do? It's similar to the previous one that we're from doing, even way simpler, because we're given 9 choose what? We're given 9 choose 3, 9 choose 7, 9 choose 3, then plus 9 choose 7. What's the first thing that we do? They are not closed because this is 3, this is 7. The guys on top are okay, the 9, 9. So what do we do? Going to be 9 minus 3, so we're going to have 9. The 9 minus 3, that gives us what? Is it a 6? So you have a 6, then plus 9 choose 7. This is going to give us something like what? A 10, then we pick 7, the bigger one. So this is the answer. It's the same as someone who had reduced this. You can say 9 minus 7. That gives you 2, so you have this. Then from here you pick this. This is the same as 10. The bigger one here is 3. You notice that these two still obey the rule because 10 minus 7 is still 3. So these two are still equal to each other. So no matter what you do, the rule is still going to be followed, that whenever you have n choose r, it's always equivalent to n and n minus r. This will always be true. It holds all the time. On here, the next question here is from binomial, so we can actually do it. They're saying find the term independent of x in the expansion of this guy here. So the last one is also on binomial. This one here, they're saying without expanding, find the interval or range of values for which the expansion is valid. We are not trying to expand it. We're just going to get the region of validity for this expression that we have been given. So let's start by getting the term independent of x. For the first part, this is 3x. So we're having there's 3x. So here, let's put this guy as a title. Let's put the term independent of x. So we have 3x minus 2 over x, and this is equal to 8. Yeah. So we're supposed to use the nth formula here, right? We're going to say provided the power is positive, n is positive, this is always going to be the case. The first term, n minus r, b to the power r, provided the nth term is equal to r plus 1. That's what we do. This is what we should be utilizing all the time whenever we're trying to get the term independent of x, or even the nth term or anything. So the n is 8. We put our 8. We don't have the r. That's what we are looking for. The first term is 3x. This is going to be 8 minus r. Then the second term is negative 2 over x to the power r. Equate this all the time. You're supposed to equate what you have to x to the power 0 whenever you're looking for the term independent of x. Because the term that doesn't have x, meaning x is raised to the power 0. From this expression here, you're going to rewrite this as 8, choose r. Then this is going to be 3, 8, power r, x 8 minus r, get the number 2 to the power r, and get the x as well, x to the power r. Then equate this to your x to the power 0. So this here is necessary because it will help you to ignore everything else and only get the portions that have x. So just get the parts that have x. This is the part that you're interested in, x to the power 8 minus r. This x to the power r, and it is at the bottom, so we put it at the bottom. That's what you have. Equate it to x to the power 0. Then from here, the bases are the same, meaning the powers are going to subtract. So you have 8 minus r minus this r is equal to x to the power 0. Then from here you can have your 8 minus 2r is equal to 0. Negative 2r is equal to negative 8. Divide with a negative 2, meaning your r is equal to 4. When you get your r is equal to 4, we can get the term now. The nth term is equal to r plus 1. So get the 4 plus 1. So the term that doesn't have, or the term that is independent of x, is simply the 5th term. That's what they wanted. You can proceed to get it. So you can just say proof r is what? 4. So we're going to say 8 choose 4. Then we have 3x to the power 4. 8 minus 4 is 4. We have negative 2 over x to the power 4. We're just trying to cross-check if the term actually won't have x by the time we're done solving it. 8 choose 4. We can keep it here. We have 3 to the power 4, x to the power 4. This is negative 2 to the power 4. Then we have x to the power 4. So this part cancels out. You notice you have 8 factorial, 8 minus 4 factorial, and then you have 4 factorial. This is the same as 3 to the power. That's what? 3 to the power 4, that's 81. So we need to write same as 9 times 9. Then this is the same as a positive 16. So this is what you get. Whatsoever number you're going to get is the 5th term. 8 by 7 by 6 by 5 by 4 factorial. Down you simply have a 4 factorial. A 4 factorial. The other 4 factorial is simply 4, 3, 2, and 1. There's a multiplication here. We have a 9 and a 9 and a 16. So this will be easy to handle because they're just numbers and we just have to simplify. This cancels with that. So we are having the 3 with that 3. With this, that's a 2. So we have this 2 and that 2. The 4 there, that's a 2. So we just have a 14 times 5 times 81, then times 16. This here is the number that you're supposed to get. So when you multiply everything, that's a constant. That's a term which is on the 5th position and it's independent of x. You see that it doesn't have x with it by the time we're done solving. So that answers your question, your second part, this guy here. Then look at this question here down here. They're saying, without expanding, find the term or the range of values for which this expression is valid. It's like them asking you to get the domain of a series or an expansion. 2 minus 3x. Is everyone okay if I write this as 2 minus 3x to the power negative 1? Then this, can I write it as this? Then I say, we have to make the first term to be 1. This is be 3x over 2. Then this is to the power negative 1. Is everyone okay? This first of all changed and became this 1. So this may be, can I take it step by step? This first of all became 2, 1 minus 3x over 2. Then this is to the power negative 1. We distribute the negative 1. This is what we get. And the region of validity is always going to be modulus of the term that is on the second part. Provided the first term is 1, we call whatsoever we have here as our a. So this is modulus of this over, this is 2 less than 1. That's always the region of validity. So the modulus makes the negative to be positive. This will be 3 over 2. We take it outside, leave x alone, divide by 3 over 2. Even this side divide by 3 over 2. So this is just going to be modulus of x. Then you have less than 2 over 3. This right here is your range of x values where this expansion was valid. Yeah, so this is how we were supposed to go about the question that we are given here, getting the range or the interval where this thing is valid. Here, since you have exponentials as well, look at question number 4. Look at this part here. Yeah, they're saying solve the exponential equation below. This is what we are given, the first one. Then look at the next one. We have this. The bases are different here. This is in base 3. This is in base 9. We also have to solve this. So the first one, I'll write it here. So this is 3. We have a 3. Then we have a 9 to the power x. Then we have a minus 28. Then 3 to the power x. Plus 9 is equal to 0. This is plus 9 is equal to 0. So the first thing that we do is reduce the 9, because we have two weird parts, right? We have the 9 to the power x and the 3 to the power x. So we need to reduce the bigger weird part into the smaller weird part so that they look alike before we replace with a particular letter. So this is going to be 3. This is 3 to the power 2 with an x. Then this is minus 28. We leave this untempered with. Plus 9 is equal to 0. This is just going to be, switch these, you can swap them because you learned under indices to say if you have this, it's the same as x to the power m. Then put the n outside, right? Then this is going to be 3 to the power x, then to the power 2, minus 28. You have 3 to the power x, plus 9. This is equal to 0. Is there anyone who is lost here at this point? Any question up to this point? Okay, so silence means there are no questions. We proceed by replacing this part that is 3 to the power x by later. So this is just going to be, we can use k. K is equal to 3 to the power x. So this will be 3k squared minus 28k, then plus 9 is equal to 0. So from here, we can divide throughout by 3. So this is going to give us k squared minus, this is what? Is it, what's 3 into this guy here? Does 3 divide 28? Leave us without a remainder, can it? Or maybe I was overthinking. Oh, I thought it's a 7. Okay, so it cannot. Yeah, we go with the long route of doing the product sum factor. You know, the product here is going to be your 27. Your product is 27. Your sum is negative 28. So your factors are supposed to be negative what? Negative 27 and negative 1, right? Yeah, so we'll have 3k squared minus 27k minus k, then plus 9 is equal to 0. From here now we have 3k, then we have a k minus a 9 minus 1, this is k minus 9, this is equal to 0. We have a k is equal to 9 and we have a k is equal to 1 over 3. I'm a little bit fast here, so hope you are able to see how the k is equal to 9 and the k is equal to 1 over 3 came about when you solve each of the factors that you are supposed to get here. Now the question was asking for x, not k. So remember that k is equal to 3 to the power x. So we bring it back. It will be like this. Then we have 3 to the power x is equal to 1 over 3. Here we can just change this to be 3 to the power negative 1, meaning x is equal to negative 1. We get this answer. Here again we have 3 to the power 2, meaning x is equal to 2. Provided the bases can be made to be the same, we carry out it like this. This is how we get the values of x. Any questions, guys, here? This is something you should anticipate where you are given different bases. Yeah, so you're having log of x plus 4 to base 3. So this is okay. We have those equations. There's log x plus 4. This is the base is 3. Then minus log. The base is 9. You're having something like what? 27 minus 2x. 27 minus 2x is equal to 0. So how do we change the bases? The key here is to change them into the smaller base. To change the guy that is in a bigger base to be in a smaller base. We change the base using this formula. If this is what you have and you want to take it to base, let's say x for instance, this is just going to be log the new base x, put the b there, over log the new base x, put this a as a number there. So this is what you have in terms of changing the base, right? So now we want to change the log 27 minus 2x, changing it to base 3. So this will be log 3, the new base is 3, log 27 minus 2x to base 3. This is equal to log, the new base is 3, this is a 9, equate this to 0. Once you change the base of this guy, we put it in base, this have been put to base 3, this is what you are getting. We can simplify the down part. This is going to be something that looks like this. Minus, here you have log, this is 3, this is 27 minus 2x. Log of 9 to base 3 is equal to what? This is just a 2. The number of times 3 has to multiply itself to give us a 9. That's 2 times. So we have given this, equate this to 0, because we can take this on the other side. It will be log 3, then x plus 4. This is equal to log 3. This is 27 minus 2x. Then down here we have a 2. Here we have that. We're going to cross multiply. It makes life a little bit easier to handle because we're going to get 2 log 3. This is x plus 4 is equal to log 3. Then we have 27 minus 2x. This is now going to give us, we can take the 2 on the other side, it becomes the power. We have log 3 x plus 4 to the power 2 is equal to log 3. Then we have 27 minus 2x. Now it will be incorrect for us to say that the two guys are going to cancel. This guy and this guy is cancelling. It will be mathematically incorrect to say that. So the best thing we can do is to bring them close to each other. So we're going to say log 3x plus 4, the power that, minus, or this is a 2, sorry, this is a 2, log, there's a 3, there's a 27, minus 2x, x, this is equal to 0. This is going to give you log 3. We have x plus 4 squared over the 27 minus 2x. Whenever there is subtraction, it changes and becomes division. We have this. Then from here, we change this from being a logarithmic expression to exponential. So we say 3 to the power 0 is equal to this. So we have x plus 4 to the power 2 over 27 minus 2x minus your 2x is equal to 3 to the power 0, which is a 1, by the way. It doesn't change anything because we still have our x plus 4 squared is equal. This is a 1, right? 3 to the power 0. 1 times this bottom part will still be 27 minus your 2x. So you see, unlike just cancelling the log here, unlike cancelling this and then equating them, you see how we have nicely shown how the log is going to cancel out. Then from here, we expand the left-hand side. This is x squared plus this is going to give us 8x plus a 16 is equal to 27 minus 2x. And from here, this is a quadratic. X squared, you have what? This is going to give us a 10x. Then the 27 goes this side, so we're having 16 minus your 27. This is negative 11, so I'm getting a negative 11 here as the C. If we were to solve this, the only feasible answers we can get here as our factors can be 11x. Let me use 11x. 11x minus x. That's what we can get. This is what you have. You have x and x plus 11 minus 1. You have x plus 11 is equal to 0. From here now, we can have x minus 1 and have x plus 11. This is equal to 0, x is equal to 1, and x is equal to negative 11. Now, just to be safe, under logs, because this can raise question marks to say, how come we're having negative 11 when logs, the domain of logs is always greater than 0, it does not allow negatives. So it may be an extraneous solution. Can we test it using the original question? So the original question is log 3, we had what? We had x plus, this is what? This is x plus 4. This is what I'm avoiding, this part. Put negative 11 here. You've seen negative 11 plus 4. You see what you get there. So this is the reason why this is an extraneous solution. It's not a true solution. This is a correct solution. Only 1 is a true solution. So this is what we get. So for logs, you always have to be testing. Yeah, so this is what you have for this part. Let me just try to find something I can give you as a task. Our session is over. Look at this guy here. So this guy here is similar to what we started with. So please, this Omar, this is yours. I would expect a response from you. This guy here, they're saying it's the same thing. They're saying 1 plus bx to the power n is expanded in ascending powers of x. The coefficient of x is negative 3 over 2, and the coefficient of x squared is 3 over 2. So can you get the coefficient, the numbers, the real numbers b and n? So we do it the same way that we did the first question that we started with. So let's end here, guys. I'll send more questions in the group on key questions on logs and this part here, which is binomial. Yeah, then we'll be able to do them tomorrow until you go right on Sunday. So this whole time I'll send the video for sampling and everything else. It's already done. I already uploaded it. I just need to make it accessible. Yeah, so let's end here.